Alright guys, so today we're going to be looking at circuits. There's two main kinds of circuits. There are circuits in series and there's circuits in parallel. So starting with circuits in series, first let's go over the components of a circuit. Right here you can see the battery. These brown thin strips are just wire. And this right here with the different colored stripes, this is a resistor. So this is your battery, this is your voltage source. You can see the electrons flowing. That's your current. Those are those blue circles. And then right here, this is a resistor. That's where your resistance will come in. So if I wanted to make a circuit in series, it sort of makes sense how you do it. You line up your resistors in series, right? You put them in like a line. So if I wanted to add some resistors in series, I could cut right here and add a resistor in series, just like this, in like a straight line. I could add another one if I wanted to. This is just adding resistors in series. Okay, so that's one kind of circuit. You can have a circuit in series. It doesn't matter where you add them. I could cut right here. I could add a resistor here. As long as it's this one loop, they're all connected like in a straight line going across. That's a series circuit. Let me clean this up. Again, here's my battery. This is my voltage source. Some wire. And we'll throw in a resistor. So right now this is one loop, but this would be a circuit that is in series. Now the other kind of circuit is called parallel. So instead of adding this in series, instead of adding it in a straight line, I'm going to add another loop that's almost parallel to this resistor. So let's add this second loop. And this is what a circuit in parallel would look like. If I wanted to add resistors in parallel, I would do it exactly like this. I'm adding in these resistors parallel to one another, and I'm creating more loops in this circuit. So that is the basics between a series and a parallel circuit. If you need to rewatch this, please go ahead and give it another watch. So let's start talking about the differences between series and parallel circuits now that you know how to build them. There's two tools right here. This one with the black and red prongs is a voltmeter. This measures voltage. And this little device is going to measure current for us. It's an ammeter. It measures the amperage or the current flowing through. So right here you can see a 10-volt battery and a 5-ohm resistor. This is just how resistive the material is, how much it wants to resist that flow of electrons. And again, this measures the current across. So you can see 2 amps are flowing. And this device measures the voltage across. So this is a 10-volt battery. If I put it on the battery, you can see it reads 10 volts. So let's stop and think for a second. Right now, you can see the current is 2 amps. There's 2 amps of current flowing through this circuit, through this closed loop. Remember, a circuit has to be a closed loop. If I open this loop right here, if I open the loop anywhere on the circuit, let's just pick right here, you can see now the electrons stop flowing and the current goes to 0. It's no longer a closed loop. So that's really important. You have to close the loop, and then you can see the electrons will flow. We'll complete the circuit. But once we have this loop, you can see right now the current is 2. I want you to think, if I add a resistor in series, if I add a resistance to this circuit, if I increase the resistance, I'm adding it in series, what do you think will happen to my current? Do you think my current will go up? Do you think my current will go down? Or do you think my current will stay the same? Let's go ahead and find out what happens if I add a resistor in series. I'll cut right here and add this resistor in series. The current was 2, and now it is 1. So you can see adding a resistor in series made my current go down. Before I added that resistor, the voltage across this resistor right here is 10 volts. And that should make sense because if there's 10 volts going into my circuit, the resistor has to take out 10 volts. So what do you think will happen if I added the resistor back in series again? Do you think the voltage across this resistor will go up, down, or stay the same? Let's go ahead and find out. We'll cut the circuit there and add a resistor instead. I'll make this the same resistance. I'll make it 5 ohms. And we will close the circuit. Once we close it, the current will flow. And you can see now the voltage across this resistor is 5 volts. It was 10, and now the voltage across this resistor right here is 5 volts. So adding a resistor in series is going to split your current between the two resistors. It's going to split your voltage between the two resistors. But the current between the two resistors, whether I put it here on this resistor or here on this resistor, the current is the same. And that should make sense because if I'm in series, I only have one loop, one possible way for my current to flow. All the electrons flowing through this resistor move forward, and now they flow through this resistor. It's the same amount of electrons, so it's the same current. Okay, so now we're going to do a very similar thing, except we're going to do it for a circuit in parallel. So right now, you can see there's 0.9 amps of current flowing through this circuit. Again, it's a closed loop. That's a circuit. It's a 9-volt battery. There's 9 volts across that resistor. I want you right now to think, if I add another resistor to this circuit, but I add it in like this, do you think my current is going to go up? Do you think it's going to stay the same? Or do you think it's going to go down like it did when I added a resistor in series? What do you think? Okay, let's go ahead and test it now. I'm going to add this resistor. Pay attention to current as I do it. I'm adding a resistor in parallel. And when I complete this loop, I'm doing it in parallel. I'm adding another loop. What's going to happen to that current? So you can see the current was 0.9. And once I added this resistor, the current actually went up. The current went up to 1.8. A lot of you probably got this wrong and are probably confused right now. How does adding a resistor increase my current? Well, one way to think of it is if you're adding the resistor in parallel, you're adding another option, another pathway for this current to flow. So if I snip this again real quick, right here, my initial circuit, there was only one way my current could go. It could go through this resistor, and that was it. If I picture it like a hallway, if you only have one path down the hallway, there's going to be more traffic jam. If I add in another path like I do when I add this resistor in parallel, I'm basically creating a second hallway. I don't care if the hallway is really, really big and open, or if it has a huge resistance. If my hallway is super, super thin, super small, only one person can fit through it. If I'm adding a second hallway, more people can walk through it. So even if it's a big resistance, once I add this resistor in parallel, you'll see this current will go up, no matter how big that resistance was. Now that we looked at current, let's look at voltage when we add resistors in parallel. So remember, initially, we said this was a 9-volt battery, and there was 9 volts across this resistor. If I check my voltage now, it's still 9 volts across that resistor, and it's 9 volts across this resistor. So when you add resistors in parallel, the voltage across them is going to be the same. They're the same voltage here across both of these loops. So in series, the current was the same, but the voltage split. In parallel, the voltage is the same, but the current is going to split. You can physically see it right here. The current's flowing, and it reaches this little point right here, which we call a junction. Now it has two paths it can choose from. It can either go up and around like this, or it can go forward like that. So the current is literally splitting right here. And you can see before the split, the current was 1.8. After the split right here, the current is 0.9. So you can see how the current splits between the two paths. That should be the basics that you need to know. You should be good to start your labs now. If you have any questions, send us a remind. And if not, good luck.